All right, so in this video, we're going to be looking at determining whether lines are skew, parallel, or intersecting. Now, the parallel case is the easiest to figure out. You're going to look at the vectors that represent the direction vector for the lines. If they are scalar multiples of each other, and you have two lines with scalar multiples, they don't have to be going through the same points or anything, but if the direction vectors are pointing in the same direction, then they're parallel. If they're not pointing in the same direction, then they could be skew or they could be intersecting. Now, intersecting would mean they actually hit each other, they run into each other, they share at least one point. On the other hand, if they're skew, then they're pointing in different directions, but they're not intersecting with each other. So they're a distance apart. The closest point is not zero. They don't share any points at all. So to figure out which ones might be parallel, we're going to start by coming up with our direction vectors. So for the top one, again, these are just the coefficients of t that tells you what the direction is. So in this case, we're going to have 6, -3, 12. And for U2, we're going to have 2, 1, 4. And then for R3, we're going to have 4, 2, 8. And for the last one, just a direction vector, not a line, 1/2, -1/4, and 1. All right, so one thing that we can look at is if I take out these two, it's clear that U3 is twice the value of U2 of U2. U3 is twice the value of U2. So they're pointing in exactly the same direction. So they are either parallel or they're identical. So the way we're going to figure that out is we're going to find out if they actually intersect at the same point. Now, typically the way that you would do this is you would find out if they share any values. You would set one equal to the t parameter, you would use s in the other one, and then you would start setting your coordinates equal to each other to find out if they're actually parallel or not. So let's take our first component, 1 plus 2t, and set that equal to 4s plus 3. If we solve for let's say s or t in this equation, let's say s, move the 3 over, you get -2 plus 2t is equal to 4s. And then if we solve for s, we get -1/2 plus 1/2 t is equal to s. And then I do the same thing in my second component. T is equal to 2s plus 1. Now I can plug in my previous expression for s to see if this is satisfied, if I get an identity. So 2 times -1/2 plus 1/2 t plus 1. T is going to be -1 plus t plus 1. Those do give me the same thing. That's an identity. So they're both satisfied at the same time. So now let's try our last component. 1 plus 4t is equal to 8s plus 5. And again, we'll try the same trick. 8 times negative 1/2 plus 1/2 t plus 5. 1 plus 4t on that side is going to be equal to negative 4 plus 4t plus 5, which is going to become 1 plus 4t. So these are the same line. They're not actually parallel because they're identical lines. Every time they're going to pass through all the same points with the relationship that we have here, that S is equal to this relationship. As long as, so they're going to be passing along at different points along the line, but they're nonetheless going to be the same, representing exactly the same set of points. All right, so then let's go back to our other vectors. If I take this vector and the U4 vector, if I multiply U4 by 12, I'm going to get the U1 vector. So these two are also pointing in the same direction, but they're either going to be parallel or they're going to be identical lines. So we can run through the same thing that we did before to see if we can come up with a relationship between the parameters, or whether there's going to be a contradiction at some point. If there's a contradiction where they're not passing through identical sets of parameters, that means they're not passing through the same set of points, and therefore they're not going to be they're going to be parallel lines rather than perpendicular lines. All right, so let's try this process one more time. So I'm going to set my two components equal to each other. 1 plus 6t is equal to 1/2 s plus 1. I'm going to multiply everything by 2 to get rid of that parameter, that fraction. And then I'm going to solve for s. I'm going to get s is equal to 12t. All right, so we try this again. 1 minus 3t is equal to negative 1/4 t plus 1. Since I already know I have a relationship for s, it's going to cancel that fraction. I'm not going to multiply. So 1 minus 3t is going to be equal to negative 1/4 12t plus 1. We're going to see if it satisfies. 1 minus 3t is equal to minus 3t plus 1. That's the same thing. 12t plus 5 is equal to s minus 1. 12t plus 5 is going to be equal to, replace s with 12t minus 1. This is going to give me 5 equals negative 1, which is a contradiction. And so what that means is that even though these are pointing in the same direction, their z coordinate, even when their x and their y coordinates are the same, their z coordinates are not the same. And so these lines are parallel. Now, so then the question becomes, what about skew and intersection? So if they're not parallel and they're not the same line, then we know that they're either skew or intersecting. So let's look at those scenarios. So we determined that 2 and 3 are the same line. So I'm not going to consider R3 at all in the rest of my analysis because it's the same line as R2. So anything I say about R2, I'm going to be able to say in a slightly different way about R3. So let's copy our lines down here so we can have them to look at. All right. Now, if we want to determine if they're intersecting, then we need to find a point on the line that they share. And if they share no coordinate points, then we know that they don't intersect, that they're therefore skew. So our procedure is going to be somewhat similar to determine if there is a point of intersection. We're going to take our two equations. We're going to try to solve the parameters as a system. And if all three equations, X, Y, and Z, all have a common solution, then there's going to be a point of intersection. If they fail to have a common solution, then they will be skewed. So let's start with R1 and R2. We know these are not pointing in the same direction, and we know that so R1 is parallel to R4. So presumably if R1 and R2 have a point of intersection, then R2 and R4 will be skewed. Because you can't intersect two lines that are parallel unless you're, So let's just double check this. So again, we would start with our 1 plus 6t, and we would set that equal to, in R2, 1 plus 2s. That's going to give us, the ones are going to cancel. 6t is equal to 2s. And so therefore, s is equal to 3t's. So then we do the next one. 1 minus 3t is equal to t, which is s in our second equation. And so if we know that s is equal to 3t, and we can already see that there's a contradiction. 1 minus 3t is equal to 3t from our previous equation. And we can see that we're going to get 1 equals 6t, and therefore t is equal to 1/6. If t is equal to 1/6, that means s has to be 3/6, which is 1/2. And then see if that satisfies 12t plus 5 is equal to 1 plus 4s. 12 times 1/6 plus 5 . 1 plus 4 times 1/2. I'm going to get 2 plus 5 is 7. And on the other side of the equation, I'm going to get 1 plus 2, which is 3. So these are not equal. So these are skew lines. Now let's see if we can get intersections between R2 and R4. So again, we're going to go back through the same process, but we're going to do this with the other two sets of equations. So 1 plus 2t is equal to 1/2 s plus 1. The ones are going to cancel. I'm going to get 2t is equal to 1/2 s, and therefore 4t is equal to s. And then I'm going to do this for the second component. T is equal to -1/4 t plus 1, but that t is switched out for an s. I know what s is in terms of t. So -1/4 times 4t plus 1. That's going to give me t is equal to -t plus 1. I add the t to the other side. And then t is going to be 1/2. And then since I know that s is 4 times t, I'm going to get s is 2. And then we check our last components. 1 plus 4t and s minus 1. And so I know that t has to be 1/2. 1/2 equals s is 2. So let's see what happens. 1 plus 2 is going to be equal to 2 minus 1. That is not the case. That's going to say 3 is equal to 1. And so these are also skew lines. Again, you would need your S and T to satisfy that third equation. And if they satisfy that third equation, then they will satisfy all three components. And then they will have a point of intersection. But if they fail to have a point of intersection, then they're skewed.